So, like I said, in this section, we're gonna have a lot of vocabulary, okay? It just is what it is, okay? So we are going to talk about, both today and tomorrow, our points of concurrency in a triangle. Today's focus is going to be these two, the circumcenter and the incenter, okay? So has anybody ever heard of the word concurrent? Concurrent. Have you heard of that? Okay. It's three or more lines or segments intersecting. Okay. So I drew three. There could be more. Okay. But we have three or more lines, rays, segments intersecting at a point. Okay. That particular point in which they're intersecting is called the point of concurrency. I'm gonna be a little lazy and I'm just gonna say point where that happens. Okay, so this point is the point of concurrency. Okay, so we are going to talk about 4 different points of concurrency, 2 of them today. 2 we're going to talk about the circumcenter and the incenter. Okay, fun words, weird words. The circumcenter is the point of concurrency of the perpendicular bisectors. So if you draw all of the perpendicular bisectors in a triangle, they're going to meet up at the circumcenter. It's true. Okay. So below here, and we'll come back to the incenter, but below here we have the circumcenter. So the circumcenter, we said, is where our perpendicular bisectors are intersecting. So in this triangle, all of these that I'm highlighting in blue are perpendicular bisectors of the sides of this triangle. Okay, that's what it is saying. The circumcenter is where our 3 perpendicular bisectors are meeting. Okay. Yeah. So if it says, hey, this is the circumcenter, then we know those are perpendicular bisectors. Otherwise, it has to be marked. Does that make sense, Presley? Okay. Now, what this theorem is saying is that the circumcenter of the triangle is equidistant from the vertices. Okay. So what that means is this center P, where the 3 perpendicular bisectors meet, is equidistant from our vertices. What does equidistant mean? We talked about that yesterday. Equal distance. So if I calculate the distance, I'm highlighting in red here, to each of our vertices, those are all the same length. Okay. So we have perpendicular bisectors meeting in such a way that they all are the same distance to the three vertices. Hey, Harry. Oh, have a donut. That was so nice of you. Thank you.
You're welcome.
I'm not gonna feel bad about it at all. Okay. So, in your folders, you have this cute little thing, I think on page 4. Krispy Kreme glaze. It's pretty fantastic. I've never been there. I really like Lamar's.
I prefer fumble cookie over.
You know. I just
No
like
way, no
the
way.
Krispy Kreme makes like some original stuff, but like I like donut places that like have all like original stuff, like custom made donuts.
I like a good glazed donut. Okay, we don't have a lot of time for chit chat. All right. W is our circumcenter. What does that mean? That means that all of these are perpendicular bisectors. I want you to go ahead and draw in those right angles because a right triangle might have to come in handy. All right. So let's answer number 1. How long is RS? How'd you get 38? Okay, we know that this is a perpendicular bisector, so these two segments have to be the same length. So put them together, we have a total of 38. Okay. Next, I want to know the measure of TQ. Remember, this is a perpendicular bisector, so if this is RQ, what is TQ? Look at us go. All right. WS. Ooh, how'd you get that? Okay, so remember that we are equidistant to all 3 of our vertices. So all of those blue lines are the same, which is 24. Okay. How about QV? This guy right here, how long's that? 21. We're perpendicular bisectors. Okay. That is terrible. Okay. Now, what if I ask you for TW? So I'm going to zoom in, and TW is right here. What are we going to do? We have a right triangle here, people. And what can we use if we have a right triangle? The Pythagorean theorem. Okay. So in pink, I'm going to highlight a right triangle. Which one's the hypotenuse? 24 is our hypotenuse. We can say that our unknown amount squared plus 16 squared is 24 squared. If I call this little guy X. Is everybody okay with how we came up with that?
I get it.
You get it, but you don't like it?
I get it, but like I understand how to do it, but like just finding the triangle.
I really don't know what you said. Well, no. It was the mumble. It wasn't the retainer. Was it meant to not be understood? Do you have a question, Harvey?
No, I understand. that.
Okay, can somebody tell me what 24 squared minus 16 squared is? 320, question mark? Can I get some confirmation there? Twenty-four squared minus 16 squared, okay? And then if we take the square root of that, x is 17.9. All right, I'm gonna give you 1 minute for you and the people at your table to work together to find WV.
We know.
Where's the right time?
So this little pink guy right here.
24 equals 24 squared.
Because we took 24 squared and we subtracted 16 squared over. Oh, do I not have calculators at your table? Grab one from right there. Ben, I'll just do it for everyone.
141. 576. 576 minus
21. 576.
I didn't get that.
11.618.
Wait, I didn't get that.
135.
Yeah, no. Talk about 135.
Square root of 135.
Yes.
11.61.
All right, Ben, how did you set up your equation?
Okay, I said x2 because that's what we're trying to find.
Okay,
Equals 21 squared because that's the bottom leg,
okay,
and then 24 the hypotenuse.
okay. So we have x squared plus 21 squared equals 24 squared. When you subtract the 21 squared, it sounded like you got 135.
Yeah.
And the square root of 135 gave you,
11.6189.
Or just 11.6.
we'll round to 1 decimal place. Okay. What's your question, Presley?
What do you subtract from?
So, we have x squared plus 441 equals 576. And so then we can subtract that 441 over. Is that okay? All right. Okay, so then let's go back to our student journal and let's talk about the in-center. Okay, so up above here, let's go back to, let's define what an in-center is first. The in-center is the point of concurrency where our 3 angle bisectors are intersecting. So the in-center is the point of concurrency of our angle bisectors. What? Given up on him. Hi, Sam. Code word. Pretzel. I brought for a snack on the bus.
Wait.
If he watches the video, we'll know.
Oh, that makes sense. He's definitely not gonna watch the
Oh, yeah,
video.
he's definitely not. Gonna-
All right. So in this triangle on the next page, you'll want to turn the page. Okay. P is our point of concurrency where these angle bisectors are intersecting. Okay. So I highlighted the angle bisectors. Okay. So, did you have a question? Okay, so the in-center theorem says that our in-centers are all equidistant from the sides of the triangle. So what that means is this point P is the same distance away from all three sides of our triangle. Now notice how we have to make the right angle, because if we're talking about the distance from a point to a segment, we have to measure that perpendicularly. That's a fun word to say. Okay, so the blue lines are angle bisectors. They're meeting at point P, which has the same distance in red to all three of our sides. Okay, so if you would go back to your folder, and we're going to do this cute little one right here. Okay, so P is the in-center. P is where all of our angle bisectors are meeting. Okay, so let's do this. I'm gonna go ahead and just to help us out, I'm gonna highlight the distances in red. What's true about all of the segments that I highlighted in red? Well, they all have right angles. They're also all, okay, they're all, okay, and so what is that distance? 13. So NP is 13. And OP is 13. All right, so let's talk about that first one, the angle MJP. What is this angle that I highlighted in purple right there? It's gonna be. These are angle bisectors.
The triangle below it is, could technically tell us.
It's 39 degrees. We have angle bisectors. Oops.
Oh.
So I'm gonna zoom in here. These two have to be the same. These are both 39 degrees.
Another technically.
Hold on. Nora, what's your question?
So is it like all the like the right angles have to be and those and it's the other line?
Yeah.
So then like
Ooh, do you agree with that? That this is 28 right here? Okay. Clark, what's your question?
Couldn't we technically say, since we know the angle below it is 39, couldn't we figure out that the other one's 51?
If we need to, yeah. So JKL. All right, people. So if we want JKL, how are we gonna figure out that angle? Jeez. Okay, so what's 39 plus 39? 78. So this is 78. angle L is 54, right? 28 plus 28. So what would, 56, sorry. What would be left over for angle K essentially? Of the triangle.
34. Oh, 20. Well,
Yeah,
46
1
would be
46.
46? Cool. So we would know if that whole thing's 36, what are the bisectors? 23. Okay. All right. KLJ, we already talked about how KLJ was 56, so that's not a new one. Okay. Let's talk about KM. Where's K? Oh, KM. What's this guy right here? How do we know that? Okay, so if we think back to yesterday with our angle bisector theorem, we know that these two sides need to be the same because we have angle bisectors and these perpendicular pieces here. It's like it was made to be. We learned that yesterday, so we could use it today. All right, so let's talk about KP and then we'll be done. KP. Ooh, I'll highlight it in green here. I am looking for KP. What are we gonna have to use to get us KP? Pythagorean theorem. I'm gonna call KP X. Which one's the hypotenuse? KP, what we're looking for. So we're gonna use 13 squared plus 30 squared equals X squared. $1,069. And what's this? 32.7. Okay. Okay, so we're not gonna do it because we're running short on time with the map testing schedule. But if we were gonna find PL, we could do the same thing. We know that this is 13. We know that this is 24. What is another measure that is 24? What else is 24? How about NL? NL and OL are both 24. You see that? Not in this case, but maybe it could help later on. Okay, pages 5 and 6 are your homework.